Okay, so this is going to be on our on 1.4 kinematic equations. So I would say this is the most important topic in this unit. In this overall course, because you do use the skills that you learn in this topic for the rest of the year. So let's begin with the do now question based on this gift. What do you think is the difference between constant velocity and acceleration? Well, clearly they're two different things, right? Constant would means stay the same. So if you have constant velocity, that means your velocity is staying the same over time. Acceleration is the change. You have changing velocity, right? Your velocity is changing. All right. And acceleration is a vector. Acceleration is a vector. So it must have direction. So I want you guys to copy it down on your notes, right? Copy it down here. Copy it down here on your notes. And once you finish doing that, feel free to pause the video because I am going to move on. And then, I ask you a question, which one of these gifts shows constant velocity, which one shows acceleration? Well, obviously the car on the top is showing acceleration because it's starting from 0 and then it's speeding up. Whereas the cheetah on the bottom is showing you constant velocity. Now kinematics, again, you realize that I'm kind of speeding through things. Kinematics is the study of the motion of objects without studying what causes that motion in the first place. And that's kinematics. I'm going to skip this video. You can watch the video on your own time. So now you're introduced to 5 variables. You might have seen them before, but I am going to introduce you guys to 5 different variables now. The first variable is acceleration, right? We measure acceleration in meters per second squared. The second variable is d, right? Distance or displacement. You measure that in meters. T will mean time. You measure that in seconds. And VI is going to mean initial velocity. And VF is going to mean final velocity. Alright, so these are what these 5 different variables mean. I want to use these 5 variables throughout this unit, throughout Unit 1. And Unit 2 and Unit 3 as well. So let's take a look. Before we go ahead, I want us to take a look at this formula. So on your reference table, if you came to class, on your reference table all the way at the page 6, you have all these formulas, right? So right now, so far we've covered this formula, and we will cover these other 4 formulas. Now, delta is what this triangle means. So when we take this formula right here, A is equal to delta V, again we call the triangle delta V over T. The delta means change in V. Otherwise, it's known as VF minus VI. So your final velocity minus your initial velocity over time. And that's what this represents here. Feel free to write that down. Feel free to pause before I move on. So that's what that means, right? And so you can write it somewhere here on your notes. Right? You can write it somewhere here on notes. Actually, just make it go to the left. Yeah. So you can write it somewhere here on your notes. And I do write the variables, the symbols here, right? So you have all your symbols known to you. And we're gonna use these formulas to solve for problems. And there's a very set of steps that I want you to follow as a beginner to solving problems. It'll also help you format your work. So let's take a look at this practice problem. Now there's a very specific set of steps that I want you guys to follow when solving problems. And step one, I'm going to repeat it verbatim. I want you to write down all your nodes. What are our nodes? What are our nodes? And our nodes are the information we get from the problem itself. And we're going to define them as 5 variables. Right? They're either going to be A, D, T, Vi, or Vf. Okay? So I'm going to go ahead and underline everything that's important in the question now. Right? Car traveling west decreases its speed from 30 meters per second to 23 meters per second in 2 seconds. And I want to draw your eyes towards the units. For example, seconds. Meters per second. And it's really important for you guys to remember what the units for specific variables are. Let's go to your cheat sheet. Right? So if you see a particular unit, you can assume that it is a certain quantity. So let's say, for example, you see the unit seconds. Well, you can assume that the variable is time. And that seems obvious, right? We measure time in seconds. So if you see 2 seconds, well, we know. I'm actually going to make this smaller. Can I make this smaller? Can view actual size? No, okay. I cannot make it small. But I'm just going to use whatever space I can then. So step 1. I'm going to write T is equal to 2 seconds. And that's our first node. This is our first node. What are our other nodes? Well, we see 2 other numbers. We see 2 other units. And they're meters per second. Well, this should be familiar to you guys. You guys measure speed in miles per hour, but in the metric system, it's now kilometers per hour or meters per second. Furthermore, you can look at your cheat sheet, right? You measure, if you see the unit meters per second, well, you can assume that it is a speed or velocity quantity. Vi or Vf, right? Is it my initial speed or is it my final speed? Well, let's figure it out. Right? Which one of these is 30 my initial or final? Is 23 my initial or final? Remember, the phrasing of the question is important. If you look down here, number 2, phrasing, if you see increases or decreases the speed velocity from number to number, well, then you know that your first number is your initial velocity and your second number is your final velocity. So we are going to write Vi is equal to, and it's something really important here that you also have to take into account. The car is traveling west. So you must actually put a negative sign there. Negative 30 meters per second. And Vf is negative 23 meters per second. Now we're done with step 1. We're done with step 1 now. That's fine. We're done with step 1. Now we're going to move on to step 2. What are we trying to solve for? Well, if you read the rest of this question, it says the car's average acceleration during this time is what? So they want to know what your acceleration is. So number 2, I'm going to write, I don't want to write it there. Number 2, I'm going to write A is question mark. We're solving for A. We're trying to solve for A. Now we're going to go back to our formulas. Right, we're going to go back to our formulas now. What's a good way to do it? Let's go about this. So let's take a look at our formulas. Try to fit everything in like one screen. So now I'm going to repeat step 3 verbatim. We're going to pick a formula that has all 3 of our knowns and what we are solving for. Right? We want a formula that can do that, that has all that. So let's start from the bottom. VF. Do we have final velocity? Right? Do we know what it is, or are we solving for it? Well, we do know what our final velocity is. We know it's negative 23 meters per second. What about VI? Do we know what VI is, or are we solving for VI? Yeah, we know what it is. It's negative 30 meters per second. Do we know what A is, or are we solving for A? Yeah, we're solving for A. So we have A there. But do we have D? No, we don't. In our problem, we don't have D, and we are not solving for D either. So we're not going to use this formula. We're going to skip this formula. We can't use that formula. Same thing here. We can't use this formula either. We don't have D. Let's look at this one. VF, yeah, we have it. VI, we have it. A, we're solving for it. And T, we have it. So we're going to use this formula to solve for our problem. So to use that formula. So we did 3, step 3, right? So the formula we're going to pick is VF is equal to VI plus AT. And so now number 4, we're going to plug in all our knowns now into the formula. So VF is negative 23. VI is negative 30 plus A times 2. Right, because that's T. We're going to cancel this 30 out because we want to solve for A. So that's 7 is equal to 2A divided by 2 on both sides. And you get 3.5 meters per second squared. And since acceleration is a vector, we're going to attach a direction to it, east. Acceleration is a vector. It's a vector, right? It must have direction. Let's move on to the second problem. We're going to do the same exact thing. We're going to identify our knowns. So, what is the final speed of an object that starts from rest and accelerates uniformly at 4 meters per second squared over a distance of 8 meters? So step 1. What are my knowns? If you want to try and see if you can figure this out yourself, feel free to pause the video and unpause when you get stuck, or to check if you're right. So the first thing I see here is 4 meters per second squared. First thing I see here is 4 meters per second squared. That's a unit for something. If you check your cheat sheet, that's a unit. 4 meters per second squared is the unit for acceleration. So you should realize that A is 4.0 meters per second squared. Next, you should see 8 meters. What is that? Well, you see the meters, so if you check your cheat sheet, meters is a measurement for distance or displacement, right? It's a measurement for length. Now we're missing a third known though. We do need 3 knowns. And the clue is in the problem. Starts from rest. Starts from rest. Well, that means something very specific, right? Starting from rest means you're not moving. And if you're not moving, well then your initial velocity is 0. Right? Your initial velocity is 0 here. So starting from rest, it's something you'll see a lot. Starting from rest means your initial velocity is 0. Now, we have our 3 knowns, so now we're going to try to figure out what we're solving for. And it's in the problem, right? It's in the phrasing. What is your final speed? So we're solving for VF. Now we have to pick a formula to use. All right, we have to pick a formula to use now. Let us start with this formula. Do we have VF? We have VF, right? We're solving for VF. Do we have VI? Yeah, we have VI. Do we have A? Yeah. But we don't have T. We don't have T and we're not solving for T, so we can't use this formula. We can't use this formula here because we don't have T. Let's check the bottom one. Do we have VF? Yeah. VI? Yeah. A? Definitely. And we have D. So we're going to use this formula here. When I say we do have VF, I mean we do have the variable, or we are solving for VF. It doesn't matter if we know what it is or if we're solving for it. I'm still going to check mark it. So we use the formula on the bottom. So 3 VF squared is equal to VI squared plus 2 AD. And so now we're going to plug in our knowns. Okay, so VF squared is equal to VI. 0 squared plus 2, 4, 8, right, 2AD. 0 is 0. 0 squared is just 0, so I'm just going to omit it. 2 times 4 times 8 gives you 64. Square root of both sides gives you 6, right? No, it's 8. Gives you 8. 8 meters per second. Okay, and that's your speed. So let's move on. Going to increase my speed now, right? Because it's pretty much the same thing over and over. We're in step 1, we're identify our known. So runner travel 12 meters, right? So 12, since we know it's measured in meters, we know D is 12 meters, right? Distance or displacement. In 4 seconds, so we know that's time, right? We know that time is measured in seconds. We continue reading the problem. It says as she accelerated uniformly from rest, right? If you're starting from rest, accelerating from rest, it means that your initial velocity is 0, right? The phrasing, you're going to see it a lot. And you want to know what the magnitude of the acceleration was. So you want to know what A is. You're solving for A. So which formula do we use? We're going to look for the formula that has everything we want. So it's going to be this one. We have D, we have VI, we have T, we have A, or we're solving for A, and we have T. So we're going to use that one. The other formulas don't have all the symbols we want. So 3D is equal to VIT plus 1/2 AT squared. Plug it in. D is 12 is equal to 0, 4 plus 1/2 A, 4 squared. 12, 0, 0, right? 0 times anything is 0. So 1/2 A, 4 squared is 16. Then you can do 1/2 times 16, right? You can actually multiply these two numbers and you get 8A divided by 8. And you get 1.5 is equal to A. Meters per second squared. Okay. Let's move on to the final practice problem. Again, I'll make this really quick. We're going to look for our knowns now. We're going to look for our knowns. If a car accelerates uniformly from rest, right? So we're accelerating uniformly from rest to 50 meters per second. And that's a certain phrase. You're accelerating from rest to this number. So we're looking at our phrasing again. So accelerates from number to number. While from rest isn't specifically a number per se, but you should know by now that from rest means that your initial velocity is 0. So we know that our initial velocity is 0 and our final velocity is 15 meters per second, right? Because of the unit. We see the unit, 50 meters per second. We continue reading the problem. It says distance of 100 meters. So D is 100 meters. And they want to know. So now we're on step 2. And so they want to know what our acceleration was. So now we have to choose. We have to choose a formula. I'm going to choose a formula now. Let's see which one works. So which formula has everything we need? If you want to pause this to figure this out and see if you're right, pause it right now. So I'm going to go in 5, 4, 3, 2, 1. So we're going to use the bottom one. All right, so we have VF, we have VI, we have A, and we have D. So we use the bottom one. 3 VF squared is equal to VI squared plus 2AD. And then 4 we'll plug into our known, so we'll get 15 squared. VI squared is 0 squared plus 2A 100. 15 squared is 225. 0, 0. 0 squared is 0, so I'm just not going to include that. 2 times 100 gives me 200. Divided by 200. 1.125 meters per second squared. Say. And that's the answer there. Alright. Hopefully this video wasn't too long. I tried to rush as fast as possible. But yeah.